The technology we're going to talk about, FX today, is intimately related to the FPGA FX, which is a unique thing about Antelope. And this is something unique to Antelope and something that we are offering with our interfaces. One of the reasons we have created FPGA FX technology is because we're trying to address the issues of sound quality, latency, and stability. What is so special about using FPGA for the effects? So what we're doing is we're actually doing hardware modeling. What does hardware modeling means? It means modeling analog hardware with digital hardware. Now it sounds like a little bit of mumbo jumbo, so let me explain. As you know, analog's desirable vintage analog electronics, the compressors we all love, the microphones, the vacuum tubes, the transformers, all these things have physical electronic properties that give them a certain sound. So we have worked with these things for many, many years. We have designed microphones and discrete amplifiers and preamps. We have analyzed tube circuitry. We have modified tube circuitry. We measured tube circuitry. We intimately understand how this electronics works, how equalizers work, how compressors work, how pre's work. All that is extremely important. So what we did was actually saying, okay, what are the qualities of these things? What is the electronic quality? What's the analog quality of this component? And then we went out and say, okay, can we use digital FPGAs to actually create a modeling system, a modeling structure that could accurately model the analog properties of these components, and that's what we did. So effectively, in our FPGA chips, there are physical blocks, there's parts of the chips that are dedicated to these specific features. There are little tubes living inside the FPGA chip. There are transformers being placed inside the FPGA chip. Not literally the transformers, but the models. Parts of the chips are 100% dedicated to modeling these particular components. So what does this do? Well, firstly, we are able to adjust and design them in a way as to achieve the sound of these things as closely as possible. Secondly, we address the issues of latency because all these things are done with dedicated digital circuits that are working and firing at the same time. You're getting literally no latency. We're talking about tiny latencies, or we're talking about latencies in nanoseconds. Instead of milliseconds people are used to. And there is the stability because these things have a dedicated function. It's not like software that's running algorithms and therefore are subject to what other threads are running, what other algorithms are running. These are extremely stable, dedicated hardware components that are then routed with little wires just as they are in the PCB boards and connected together, and that's how you create the sound of specific unit. So if a particular unit has a transformer, then say a tube, then a particular type of a detector circuit, then we literally connect the transformer modeling engine to the tube modeling engine, recreating the topology of the original analog unit. We believe that our models are unique and they are uniquely optimized to carefully recreate the sounds of the original analog equipment.